Hello everyone. Today we're starting the lesson on the sum and difference formulas. The sum and difference formulas allow us to find the sine or the cosine of the sum or the difference of any two angles. And so we're not limited now to finding the sine or the cosine of the 16 major angles that you found on the unit circle, or the angles that you can produce using those triangles. So to find the sine of the sum of two angles, we do the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. In this problem, or in this example, these formulas we're using alpha and beta. We could use any two angles. To find the cosine of a sum, you do cosine of the first times cosine of the second minus sine of the first times sine of the second. To find the sine of the difference of two angles, we use sine of the first times cosine of the second minus cosine of the first sine of the second. Let's make sure that we're on the screen. It looks like we are, even if I'm not, but that's okay. For the cosine of a difference, we use cosine of alpha, cosine of beta, plus sine of alpha times sine of beta. Now, to apply one of these formulas, let's find the exact value of the cosine of 75 degrees. Now, the cosine of 75 degrees isn't on the unit circle, and we can't do a triangle, at least one of the 30, 60, 90, or 45, 45, 90 triangles to find it, but we can use one of the sum and difference formulas. Notice that 75 degrees is the same as 45 degrees plus 30. And we know how to find the cosine of each of those. So we can break apart this cosine of 45 plus 30 degrees using the cosine sum formula. And so let's apply it. 45 is our alpha, 30 is our beta. So we use the cosine of alpha times cosine beta minus the sine of alpha times the sine of beta. So to find each of these, let's draw two triangles. One of them giving us 45 degrees, and another giving us 30 degrees. 30 degrees gives us a 1, 2, root 3, and the 45 degrees, a 1, 1, root 2. So then the cosine of 45 degrees is adjacent over hypotenuse. The cosine of 30 degrees is root 3 over 2. Minus the sine of 45, opposite over hypotenuse, times the sine of 30, which is 1/2. Multiply. Since we've got common denominators, we can combine like terms. We can subtract the two fractions. Subtract the numerators, use the denominator. Now, since we've got a root in the denominator, let's rationalize the denominator. That denominator now becomes root 2 times root 2, which is 2. Multiplied by that 2 gives us 4. Now, use the distributive property. Root 2 times root 3 is root 6. Root 2 times 1 is root 2. And now we found an exact value for the cosine of 75 degrees. Continuing on now, let's expand, evaluate, and simplify the sine of x minus pi over 4. Now this is a difference sign, and so we would use the formula in the upper right-hand corner. X would be our alpha, pi over 4 would be our beta. Now let's remember that pi over 4 in degrees is 45 degrees. So we have sine of x times cosine of 45 degrees minus cosine of x times the sine of 45 degrees. Sine of 45 degrees is a 1 root 2. Opposite over hypotenuse for the sine of 45 degrees. Same with the cosine of 45 degrees, 1 over root 2. So we've got the sine of x, cosine of x. Multiplying sine times 1 is sine over root 2. Cosine over root 2. We've got a common denominator, so let's subtract the fractions. Sine of x minus cosine of x over root 2. Then rationalize the denominator. Multiply by root 2 over root 2. Denominator then becomes 2. Distribute the root 2 to each of the terms, and we have root 2 times sine of x minus root 2 times the cosine of x. Next, let's solve this equation. Remember, solve means find what x is. X is an angle in this case. Now, this looks like a real mess, but what I would suggest that we do is that we take this term and switch it with this term. We can do that because we're adding, and the commutative property is true. So let's do that first. Now, what I'd like to point out is this. This expression here looks a lot like that expression there, because we have the x is the same in these two spots, just like alpha is the same here. 2x is the same in these two spots, just like beta is the same there. And we've got cosine, cosine, sine, sine. So essentially, what we can do is we can do this difference formula backwards. So instead of writing this long expression, we can write the shortened form, which would be the cosine of this angle minus this angle, x minus 2x. Bring down the equals, root 3 over 2. Now inside this parentheses, we can simplify. Because we've got x minus 2x, that simplifies to negative x. So we know that the cosine of negative x is root 3 over 2. Now remember, earlier this year when we were studying even and odd trig functions, we said that cosine was an even function, meaning that the cosine of negative x is the same as the cosine of x. As a result, instead of writing cosine of negative x, we can write the cosine of x. Now at this point, we're asking which angle has a cosine of root 3 over 2. So let's draw a triangle. Cosine is positive in quadrants 1 and 4. So let's draw two triangles. Root 3, 1, 2. That would be a 30-degree angle. And then root 3, negative 1, and 2. This also has a cosine of root 3 over 2. And this angle is 330 degrees. So our two